Lesson, you guys are going to be learning about section 6.6. It is all about trapezoids, isosceles trapezoids, and kites. So if you take a look at that property sheet that you guys have in your OneNote there, we have the last three quadrilaterals here. They are all four-sided shapes, but they are not in the family of parallelograms. So parallelograms, if you kind of look here, are rectangles, rhombuses, and squares. However, a trapezoid, isosceles trapezoid, and kite are not parallelograms, which we will learn. So let's go ahead and let's jump into this. So a little bit about trapezoids is a trapezoid, again, is a quadrilateral, and it only has exactly one pair of opposite sides parallel. That is a little bit different, a lot different from our parallelogram, because in our parallelogram we had two sides parallel. In our trapezoid we just have the one. So we have A, B, and C, D are parallel. Then we know, well, if it's a trapezoid, then AD and BC will not be parallel. Okay, so that's the big things about our trapezoids. Okay, so now let's go ahead and talk about the vocabulary, all the little pieces of a trapezoid. So a trapezoid, the parallel sides, so the sides that are parallel are called the bases. So A, B, and DC, or CD, sorry, CD are bases. So this is a base. So I'm going to say base 1 and base 2. Okay, then we have the non-parallel sides. The non-parallel sides are called the legs. So we have here AD is a leg and BC is a leg. So AD and BC. Alrighty, so we have those. Now, angles formed by the legs, by a leg and a base, are called base angles. Okay, so we'll have here then D, and I actually don't want to do that. I'm going to do this here. I'm just going to put a dot here. So angle D and angle C are base angles. Angle D and angle C. And then we also know that we have angles, and I'm going to put like a star here, angle A and angle B. So angle A and angle B. Now these angles are not congruent to each other. We will learn what we know. We will learn things about them, but we know they're not congruent to each other. We just know they're base angles, okay? So the next thing we have here is the mid-segment. So the mid-segment is this lovely line here. So NM is the mid-segment. Okay, the mid-segment gives us midpoints. So N is going to be a midpoint and M will be a midpoint. AN will be congruent to ND, so AN is congruent to ND. And then we know that BM, segment BM, and segment MC are going to be congruent. Okay, so at any point, just pause the video if you need a second to write. So because we know that the trapezoid, all we know is that these sides are parallel, we can't say anything else is congruent. Okay, that is it. So all we have here is this. This is it. Okay, now, in an isosceles trapezoid, this is where it gets fun. Okay, so this is where it gets fun. Because the trapezoid, the only thing that you know about a trapezoid 110% when it comes to proving is going to be the parallel sides. That is it. That's it. Yes, we have the mid-segment here, so we can use that to help us, but when it comes to proving, this is it. Okay, so when we are proving that it's a trapezoid. With an isosceles trapezoid, an isosceles trapezoid is a trapezoid that the legs are congruent. So remember where the legs are. The legs are those sides. The leg, and this is a leg. They are congruent to each other. And then, of course, we know our bases are parallel. So AD is parallel to BC, and AB is congruent to DC. Next, we have in our isosceles trapezoid, each pair of base angles will be then congruent. So again, in our parallel, these are parallel, parallel. Our base angles are congruent. So we have angle A, C and angle B are congruent. Angle D is congruent to angle A. So we have those congruent. The next thing I want you to notice is D and C. angles D and angle C, those are going to be consecutive. When we add those, we can set it equal to 180. Now, so I know I could do then the measure of angle C plus the measure of angle D equals 180. You can also do that with the measure of angle A plus the measure of angle B equals 180. Now, I want you guys to think about this. Okay, so let's go a little further here. I'm going to actually take these lines, these parallel lines, and I'm going to make them longer. Making them longer. And I'm also going to take these lines here. I'm just going to do DC for right now. DC. If you go ahead right now, all of you, cover up this whole side here, and I'm going to erase it just so you guys can't see it for now, so just don't think about it. This angle here, angle C and angle D, those are consecutive angles. Remember our parallel lines, alternate interior, alternate exterior? Those are consecutive. So we know if we add those up, they're going to equal 180. So remember, because of those parallel lines, because you know those are going to be consecutive, and you can add them and set equal to 180. So now, thinking about that, you can also do that same exact thing here with our triangle. I'm sorry, our trapezoid, a regular trapezoid. Because you know that these lines here are parallel, this is like if we just had two separate transversals, right? These transversals are totally going to intersect. Pretend that's a straight line. They're totally going to intersect, but you know that we can easily find these angles because we can add them and set equal to 180. Add these, set equal to 180 if we needed to. Now, going back to over here. Next thing we know, okay, so this is just the converse of that theorem. So remember, converse is just the reverse. So here we have a trapezoid. These segments are parallel, okay? Then we know that angle C is congruent to angle B. Oh, okay, well, that means, Ms. Gelhard, that we totally just have an isosceles trapezoid. Remember our regular, when we're talking about just isosceles triangles, and we know when those two sides are congruent, we know the angles are congruent, and vice versa. If I were to say, okay, I have a triangle and those base angles are congruent, well, I know I can say then those sides are congruent. So it's just going opposite direction. Next thing are the diagonals. Diagonals are congruent. So here we'll have DB is congruent to AC, and that's it. Let's say DB was 15 and AC was 15. That's about it. Nothing else fancy. Again, this is isosceles trapezoid, so we would have some special things here. Angles are not bisected. Please know that. Nothing here is bisected with those diagonals. Okay. So then taking a look here, we have this lovely formula. It's called the midsegment of a trapezoid formula. So here, remember, this is a base, this is a base, this is a midsegment. Okay, so this formula is directed towards this problem here. The overall midsegment formula is when you go ahead and take the midsegment, set it equal to 1/2 times the base 1 plus base 2. Okay, this is literally just if you did the average, or it's just identical to our midpoint formula. So remember when we have the midpoint, x, and then y is equal to x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. It is literally the same thing. You're going to add the two bases and then divide it by 2, and you'll get that mid-segment. You'll get that value, that length. Okay, so remember this formula. This is something you're going to put on your graphic organizer. Next here, we have these examples. So FE is the mid-segment. So go ahead and mark that. FE is the mid-segment. Okay, so we know that we can use a lot with that. If it's the mid-segment, I know that E is a midpoint. So AE is congruent to ED, and BF is congruent to FC. Okay, and this trapezoid is going to be used for problems A, B, and C. Okay, so here it says if AB is 10 and CD is 40, well, remember, this is a base, and this is the mid-segment. Okay, so we're going to use that formula. So mid-segment equals 1/2 times base 1 plus base 2. So here we're going to have the mid-segment, and I'm actually just going to put the letters for it. So we have EF equals 1/2 times 10 plus 40, which is going to be EF equals 1/2 times 50. So then we'll get here EF will equal 25. Okay, so this length is going to be 25. Okay, so next problem we have here is AE is 6x, so I'm just going to move some stuff over so it's just a little easier to see. I'm going to move that over here. So AE is 6x, ED is x plus 35, and remember, because this is bisected, right, because this is the mid segment, or sorry, this E is the midpoint, we can do 6x plus, or sorry, equals, 6x equals x plus 35 to then solve. So then I subtract x over. So then we'll get 5x equals 35, and then x equals 7. And then we're going to go ahead and plug it in. So 6 times 7, we'll get 42, x plus 35, so that'll be 7 plus 35, which will be 42. So then if we were to find, so this is going to be AE equals that, and then we know that ED equals 42, and then AD is just going to be when we're going to add them all together. So that's going to be 84. Okay, next example, again, this is referencing the trapezoid above. This is saying, well, what if it's an isosceles trapezoid? Okay, so I'm going to go ahead and draw it. I'm just going to draw it down here just to get it in our space. So taking a look here, A, B, C, D. Okay, so I'm going to go ahead, angles 1, 3, 4, and 2. So 1, 3, 4, and 2. Okay, and it made my D an O. Let's fix that, or a circle, I should say. Okay, so taking a look here, we know that angle 1 is 3x plus 5 degrees. Angle 3 is 6x minus 5 degrees. We need to find all the angles. Now, taking a look here, because it's isosceles, we know those base angles are congruent. Okay, so angle A is congruent to angle B, angle D is congruent to angle C. Now, however, we can't go and set those equal because those angle A and D are not congruent. Angle A and D, remember, because it's isosceles and just because it's a trapezoid, we know that we have these parallel lines. And if I extended this, those two angles, angles 1 and angle 3, those are consecutive angles. So we can do 3x plus 5 plus 6x minus 5 equals 180. And then when we solve, we'll get 9x equals 180, and then x equals 20. And then to find the angles, we're going to plug it in. So we have here 3 times 20 plus 5. We're going to get 65 degrees. So this angle is 65 degrees. We know angle 2 will also be 65 degrees because those two are congruent. What you could do is just 180 minus 65, and we'll get 115 degrees. Or you can go ahead and do 6 times 20 minus 5. So this angle will be 115 degrees, and this one will also be 115 degrees because it is congruent. All right. Again, just a reminder, if you need me to slow down, pause the video, and then press play when you're ready. Okay, next we're going to learn about kites, and this is the last thing. So kites is a quadrilateral. Okay, so a quadrilateral is a kite if two pairs of consecutive sides are congruent, but no pair of opposite sides are congruent. So that means here, AB and AD, those are totally consecutive, those are congruent. Then we have here BC and DC, those are consecutive sides, so those two are congruent to each other. So let's say this is 10, this is 10, this is 82, and this is 82, okay? Next, we have here diagonals. Okay, so diagonals in our kite are perpendicular. Yay, awesome. You will always be given this information usually, or given some type of information to help you lead to know which sides are congruent. So AB is congruent to AD, BC is congruent to DC. Now, another thing, okay? So another thing about a kite is if I were to take this D and I were to take it and fold it in half, so fold the paper in half at AC and flip it up, this would cut the kite in half perfectly, which means that this segment here, AC, is bisecting that angle. So we know that this angle is going to be congruent to here, and this angle is congruent to this angle. Okay, so they're not congruent. Please know that those angles are not congruent to each other, but I know that that line AC is going to bisect that angle. Okay, normally we would prove this in a proof, but since we're not doing proofs in this section this year, we are not going to have that proof to get it there, but as we know, those will be the congruent. So let's say this whole angle was 100 degrees. This would be 50. This would be 50. And let's say that this was then 40 degrees. This would be 20. And this would be 20. Okay? Alrighty. So let's go ahead and move on to this next part. So kites, exactly one pair of opposite sides are congruent. Sorry, opposite angles are congruent. So the opposite angles that are congruent are angle B and angle D. These are the only two that are congruent. Angle C and A are not congruent. Remember, that is when we have that segment, that middle line, if I can draw it straight, going down the center. And if we were to fold this kite in half, these would be bisected. These angles would be bisected. Okay? All right, moving on to these examples. So in our kite, QR is congruent to TR, or TQ. RS is congruent to ST. So it says RQT is 60 degrees. So the entire angle is 60. Ooh, okay, cool. All right, QRS is 35, 135. Okay, so a couple things. We definitely know this is 90, right, because it's the diagonals are perpendicular. So we know QTS is also 135, right, because these two angles are congruent. Do we have that on our list? QTS. Oh, we do. So this is 135. And then next we have, so since this angle, the full angle is 60, and I know that these two are bisected, right, because if I were to fold this kite in half, I know that this would be 30 degrees, and this would be 30. So do we have a RQS? No, but we have, let's see, do we have a RQP? Oh, we do. We have an RQP here. RQP, well, that's 30 degrees. Okay, right? RQP is this angle here. It's this angle here. So that would be 30 degrees. Awesome. So having that marked, that's super helpful. We know that this here, again, is 90 degrees. 90, if I can draw that nicely for you guys. 90 degrees. Okay, so if we look at this triangle, if we look at triangle QRP, we know that one angle is 30 degrees plus the other angle is 90 degrees. If we go ahead and do 180 minus those angles, we are going to get this part of this angle here. Okay, so we'll get 60 degrees. So this part of this angle would be 60 degrees. Then if we do 135 minus 60, well, we'll then just get the leftover. So this angle here would be 75, right? Because 60 plus 75 is going to give us 135 degrees. Now, let's see here. QRT. Oh, perfect. That's 60. We got that one. We just did that. RSP. Oof, this guy over here. All right, so a couple things, you guys. If we look at this triangle, this is totally a triangle, isn't it? We could do 180 minus 90 minus 75, and we'll get 15 degrees. Beautiful. That's 15 degrees. What we could also do is, I know, and you guys know this, that the sum of all the angles in a quadrilateral is 360, so you could do 360 minus all of the angles. So 360 minus 60 minus 135 minus 135, you will get 30 degrees. Divide that by 2 to split it between these two angles because these two we know are congruent to each other. Okay, next we have this problem. I'm just going to set it up because this video is already getting way too long. So we know this is a kite. We are told that RS is congruent to RU, ST is congruent to TU. So we can go ahead, do 2x minus 12 equals 2y minus 10. We can't solve that because we have an x and we have a y, so we're going to come back to that. The next side's over here, we get 2x plus 7 equals 3x minus 2. Awesome, we can do that. So you'll end up getting x equals 9. From that, you'll plug that into this x to then solve for y. All right, thanks guys for watching. If you have questions, let me know. You guys are going to go ahead and start working on your homework. Your homework here is this page, okay? So it's 10 questions. I really want you guys to focus on 1, 2, 3, 4, 5, 6, 7, 8. Try to be a rock star in those ones. Get those questions answered for those. 9 and 10, try your best, okay? I try to give you guys some hints here, as you can see. Try your best on this one. We're going to definitely talk about this more on Thursday, the next day that you are in person, okay? All right, and then your next part of your homework is this lovely graphic organizer. The graphic organizer, please read these directions on top. You're going to fill this out beautifully. You're going to use these examples that I have attached to reference as points of kind of what to put under each shape, okay? What to put under each shape. So if you have any questions,